Welcome! You're tuning in to the Ways of a Wise Well-Being podcast, the show that explores the dynamic relationships that affect and create healthy people and planet. I'm your host, Andrea Larson, community herbalist and registered holistic nutritional consultant. Welcome to episode 2 of the Wise Well-Being podcast. I'm here today to speak about Lyme disease. And before we move forward, I just want to point out that Lyme is only one strong infection our immune system might need to contend with. And a strong immune system can overcome any bacterial or viral infection. And therefore, we need to put the focus on creating resilient immune systems and not on attacking or declaring war on the other as far as organisms go. So this means a strong focus on nutrition and herbal therapy as an integrative part of how we create health going forward. But today we're going to bring it back, talk about Lyme disease, talk about ticks and transmission and what we can do to support our bodies. So the first thing that people usually want to know is, well, is Lyme disease even in my area? And here where I am on Vancouver Island, it was only very recently, even a few years ago, that officials even acknowledged or accepted that Lyme was here. Medical boards and health authorities had inaccurate information, and they were told that they weren't even supposed to test or it wasn't necessary to test, and they just weren't trained about the issue. And so a lot of people, if they got testing, it was inadequate, and if they got treatment at all, it was often inadequate. So there's been a lot of a change in politics in how in my area Lyme is acknowledged and dealt with, and that's great. There's been a lot of development in that area. But as far as wherever you are on the planet, there is no Lyme-free pocket anymore of protection because Lyme can travel in various arthropods, most notably ticks, but not exclusively. But we'll talk about why ticks are especially more likely to cause an infection. But it's a lot of arthropods, and ticks feed on over 300 different species. Over 60 species of birds are known to commonly carry ticks. You can think of lizards and mice and rats, which we know are everywhere, and rabbits and raccoons and cats and dogs, and yes, deer. So everyone talks about deer ticks and the risk of being in an area where there are deer, but it's not only deer ticks that can transmit Lyme bacteria. And it's something to be aware of that while there are differences with soft shell ticks and hard body ticks and transmission, any species of tick at any developmental stage, that's right, any developmental stage has the potential to allow for transmission of infection. So the testing is a big deal because the test that we're using currently, one of the major ones is the ELISA test, and that looks at blood serum for antibodies. But in some studies, 40% of people already confirmed and known to have Lyme who had the characteristic bullseye rash, which, by the way, a rash only occurs in 30% of people at all after being exposed to a Lyme infected tick. And only 9% of people actually develop the classic bullseye. So in this study that was done, or these studies, 40% of the people that were already confirmed and known to have Lyme who had that bullseye rash actually tested negative. So that's really not very trustworthy as far as accuracy of that test goes. According to expert Stephen Herod-Buhner, who has written one of the best and most thorough books on Lyme disease that I've come across, he says that the best test so far is advanced laboratory Lyme, and apparently that one's 92% effective, but it can take a couple of months to come back and get a result. So we really shouldn't rely on the ELISA or the Western blot or even the advanced laboratory testing to give a confirmed 100% conclusive yes or no. We should be taking clients and patients, for exactly what's going on with their individual symptoms and treating them for what's going on as a person and not based on a test result. So let's get back and talk about ticks specifically for a bit, because if other arthropods can carry the spirochetes that can lead to Lyme disease, then why is the route of transmission most commonly coming from ticks? And that's interesting because it has to do a lot with the tick saliva. So tick saliva actually inhibits neutrophil function. It hampers the complement immune system and our natural killer cells, and it even diminishes macrophage activity and cytokine production, such as interleukin 12 and interferon. And it also decreases T cell proliferation and inhibits dendritic cells, which are our main antibody cells. So all of that is happening just because of tick saliva and its chemical makeup. And so if we got bit by a tick or another arthropod and the tick saliva wasn't inhibiting our complement immune system, then infection would not be able to occur. We would actually be able to just nip that in the bud and stop it right away. But because of the activity of the saliva, it's another layer of weakening of our defenses that we need to work through. So a lot of you might be thinking, well, what the heck is this complement immune system? And without getting really overly sciencey and losing a lot of you, it's basically just a part of your immune system that's part of our innate immune system. So rather than our adaptive immune system, it's just there, we're born with it, and it works all of the time. And it's most of the proteins that are involved are actually plasma proteins that are made in the liver, and there are about 30 of those, but 9 key ones involved. And what happens is basically when these complement proteins attach to cells, there's an enzymatic process, and that will lyse infected cells. It allows water and ions into the cell and the tissue so that it basically absorbs so much fluid that it bursts open. And that is automatically happening when foreign particles and things are infecting our cells. And so we don't have to have specific antibodies and things involved for that to be working for us. So I've heard so many stories from people that will go to a doctor and they'll even bring a tick with them, and the doctor or the whoever's looking at it will say, oh, that's not the right kind of tick, you're fine, that's a dog tick, or that's not the kind of tick that can give you Lyme disease, you just don't even worry about it, which is not very scientific, because you can send whatever tick has bitten you, if you have it and it's alive, you can send it to a laboratory where they can actually test the tick itself for the presence of infectious bacteria. And even though the Lyme group has a very specific number of spirochetes that are known to cause infection so far, there are actually a lot of co-infections that are typically, as a rule of thumb, more often present than not. So it's not just the Lyme group that you want to be looking out for. Ticks can transmit all sorts of other infections, and often at the same time as transmitting Lyme infection. And so it's not just deer ticks only that can transmit Lyme disease, unfortunately. Any tick at any developmental stage has potential to transmit infectious bacteria, including those in the Lyme group and relapsing fever group. So there are and why is that? Like, why do we have this explosion of this, what a lot of people are calling the Lyme epidemic? And it's because ticks feed on so many different species of animals. I mean, you can think of, there's over 60 different species of birds that are known to carry ticks, and lizards and raccoons and rats and mice, which we know get everywhere, and dogs and cats, so your household pets even, and rabbits, and of course deer. So ticks are not exclusively on deer, not even deer ticks. And so any animal that is, especially mice and rats and rodents, those are low to the ground and going through bushes, and they can easily pick up ticks, and then they spread those all over the globe. So there really isn't a safe pocket anymore where you can be free of the risk of developing Lyme infection. If you are, you can be out in the woods, or you can be just on a grassy park in a city, or even just in your home and be cuddling a pet that may have picked up a tick that is partially fed and then attaches to you. So we need to be aware of it and understand that, it's not just a certain type of tick. It's not only adult ticks or only young ticks. a certain percentage of ticks will actually be born already infected. So it's any stage, any type of tick. We don't want to rule out the possibility, and we want to treat it accordingly by removing it safely and cleaning the affected area and making sure we watch out for symptoms and treat it appropriately as needed. And so just a few more interesting facts on ticks. Unfed ticks, so ticks that haven't had a blood meal, can live up to 7 years without a meal. So more commonly, they only survive for a couple, but they can live unfed anywhere up to 7 years. That's a very long time. And both hard and soft ticks, like I mentioned before, can transmit it, although soft ticks tend to transmit infection faster than hard-shelled ticks. So what is that transmission time? Well, there are a lot of factors that can influence that. So a lot of people think, oh, if I get a tick off within 24 hours, then I don't have to worry at all. And that's just not true. That's a complete false fact that's just wrong and inaccurate, and it gets shared and spread all over the place. But the science does not show that. And also, when you find a tick, I mean, most of us don't know when that tick attached, and we can't tell exactly how many hours it's been on there. And it's not like the tick has a stopwatch that's counting down the exact precise 24-hour clock that when it gets to, to 24 hours, boom, the bacteria is then suddenly released. That's just not how it works. So like I mentioned, soft shell ticks will transmit infection more quickly, so the species of tick has something to do with it, but also the species of the specific bacteria also will affect the transmission rate. So we know that it's somewhere at the very shortest about 10 minutes. And that sounds like a kind of a scary time frame, but it's something that we need to be aware of, that yes, a tick can transmit infection in as little as 10 minutes, and generally at the upper range of about 72 hours. But 24 hours is not the golden standard anymore. In fact, 16 hours is a very, very common transmission time. And other factors that will affect the rate of transmission of that infectious bacteria from the tick into your body are co-infections. So as I mentioned before, there are lots of other types of bacteria that can be in a tick and cause infection in humans. And so co-infections are very common, and having more types of bacteria in a tick, so different co-infections, actually speed up transmission of Borrelia Lyme causing bacterial infection. And that's a rule, not an exception. So most ticks have more than one type of bacteria. And also a partially fed tick will transmit infection much, much faster than a tick that's had an empty stomach or has not been feeding. And that again is more common than, it's not an exception, it's more of a rule. A lot of ticks will do partial feedings and then drop off and find a different host. So that's not something that can be ruled out as an exception. It is something that is legitimately happening on a larger scale, and we need to not rule that out. Just have to have a sip of water there. Where were we here? So talking about transmission time and what can speed that up. Also your immune system. If you have a very strong immune system, even the strongest type of tick with the strongest type of bacteria, lots of co-infections, whatever's going on, if you've got a strong immune system, you can actually not only thwart any chance of having the infection take root in your body, but you can actually produce antibodies to tick saliva. So it really is key to focus on overall health and managing your stress levels and what you're eating and just how your overall immune system is functioning, because you'll be much less likely to be able to be susceptible to infection from ticks or anything, including viruses and parasites and all sorts of things. So the reason that we don't have as much information as we wish we did, or sometimes as much as we think we do, about Lyme disease and Borrelia bacteria is because spirochetes in general are very, very difficult to study. There are four known genera of spirochete bacteria that cause disease in humans. So that's Leptospira, Borrelia, Brachyspira, and Treponema. And of those, you can think of syphilis as a great example. Syphilis is in the Treponema genus, and after decades and decades of focused research, like over 60 years of dedicated, focused research, it still can't even be grown in a laboratory. And what's more, even if scientists can grow some of these bacteria in a petri dish or a test tube scenario, it's very, very different than how these bacteria behave when they're in a live host. And bacteria, like all things, have innate intelligence to basically sense what's going on in an environment and then alter their behavior and respond accordingly. And that's what they're doing when they get into a live host, so be it an animal or a human being, which we're just a type of animal. When they get inside of us, they're constantly sensing where they would have the highest chance of food and being able to survive. So let's talk more about Borrelia bacteria in general. So right now there are currently about 20 in the Lyme group and another 15 that are in the relapsing fever group. And more are being discovered and added to these groups all the time. And bacteria in the Borrelia group are incredibly fast. They're actually 2 times faster than our own neutrophils, which are our fastest white blood cell. And an interesting thing about Borrelia bacteria is that they don't require iron to live. They actually use manganese instead. And another thing that is really makes it especially applicable to what we're talking about is they have the largest number of DNA replicons of any known bacteria. So that means every time that they reproduce themselves, their offspring can use 24 extra pieces of DNA to facilitate making very different to slightly the same or rapidly different offspring genetically. So they are a little actually a bit slower than most bacteria as far as their reproduction rate. They produce a new generation every 8 to 12 hours, where a lot of bacteria can reproduce every 20 minutes. So Lyme bacteria are actually capable of only minimal metabolism. All their nucleotides, amino acids, fatty acids, enzymes, cofactors, that must be scavenged from their host. And one of the most important things we should always know and keep in mind and understand about Lyme bacteria, so the Borrelia, is that they have an affinity for collagenous tissues. And this is where most of their needed food components are. So the damage to these structures is at the root of every symptom that they cause in the body. And if you protect the collagen structures of the body, then the symptom picture begins to disappear. So let's specifically talk about what happens when an infected tick bites you in the body. So the tick attaches, it bites to you, and bacteria in the salivary glands can go right into you at that point, or so if it's been partial feeding, or the blood meal makes it to the midgut, and then the bacteria travel from the midgut to the salivary glands. They analyze that blood meal, and then they make rapid multiplication and alterations of themselves and their genomic structure based on that 24 extra DNA pieces to get ready to flood your body with thousands of different bacteria that are structurally and genetically having a wide variance. And so they're trying to get themselves as tailored and adapted to your specific body as they can. And then once that tick has bitten you, that saliva has hindered your complement immune system. And as those bacteria enter your body, they're all varying slightly and they move quickly through your body. Some will attach to endothelial cells of the blood vessel walls, some to white blood cells, some to keratinocytes, neurons, or glial cells. And they cause those cells to engulf them and create a vacuole. And in that vacuole, they start to reproduce. So the bacteria that don't go on to attach to those structures will actually try to locate the extracellular junctions instead of cells. And they wriggle in there and they penetrate them and they initiate responses to further weaken or loosen those junctions and gain access to the extracellular matrix, which exists between all of the cells in your body. And all of this can occur in as little as 10 minutes after the initial tick bite. 10 minutes. So that's a lot of stuff happening in a relatively short amount of time. And I want to bring up another issue about tight junctions and our extracellular matrix, in that in the body there's another substance that we are constantly exposed to, and that is glyphosate. And glyphosate weakens our tight junctions in our cells. So not just in the gut, that's probably the very first place, but also in our blood vessels, and also in our blood-brain barrier, and also in our kidneys. And so that is a really important thing to think about, is that a lot of us already have damage to those structures because of environmental toxicity. I mean, a huge, like more than half of our water and our air is contaminated by glyphosate residues, and that has an impact on our body. And so if we've already got damage to those structures, then it's even easier and we're more susceptible for these Borrelia bacteria to get in there and start to weaken those junctions further. So the ECM is an ideal location for these bacteria because it has an ample, when I say ECM, I mean extracellular matrix, it has an ample food supply, and it's really hard for our immune cells to get to. So when the bacteria inside so let's go back a step. So the bacteria that decided to attach to various cells in our body, they're inside vacuoles. And after 48 hours of replicating themselves in there, they will have created dozens of new spirochetes. And hidden inside our cells, they can resist antibiotics for a minimum of 14 days. So spirochete levels tend to peak at about 60 days of infection, and then they actually drop to extremely low levels, which are easily missed by tests in our system. So the recombination of those 24 extra DNA segments continues to occur as the bacteria continually restructure and replicate themselves to gain deeper access and colonize different parts of the body. Therefore, they produce more intelligent offspring that are more and more adapted to your body specifically. And they can actually even go into encysted forms, which are an inactive form, and they can stay there for up to 3 years. And they also create biofilms in the body. About 2% of bacteria that are in the tick will actually go towards doing this right away. And they'll set up a biofilm, which is basically a community of bacteria, other species of bacteria as well, and other fungi, and they build little cities out of various molecules, like for example, your dental plaque is a biofilm. And if your gut is healthy, you actually should have a biofilm of healthy bacteria lining the entire gastrointestinal tract. But often we have biofilms of pathogenic bacteria that are not in line with our mutualistic design. So our bodies are actually very good at killing encysted bacteria. Our neutrophils make something called a neutrophil trap, a neutrophil extracellular trap, which is one of the ways that our immune system can trap and kill them. So our neutrophils don't actually live very long, and when they know that they're either going to sacrifice themselves or that they're nearing the end of their life cycle, they'll actually make that trap. It's almost like they're casting a net from their DNA, and that will actually be able to catch and stick those encysted forms of bacteria to them. Another thing that I want to point out at this part while we're talking about neutrophils is that sugar, actually high doses of sugar, and not even that high dose, like several teaspoons or tablespoons even of processed sugar, will knock out your neutrophils for hours and hours in the body. And so when you have a high sugar diet, your immune system again is already depleted and functioning at a suboptimal level to be able to deal with not only an infection if you were bitten by a tick, but also any potential disease-causing viruses or bacteria or parasites or other organisms. So before we move on to treatment protocols and what we can do to support the body, especially when antibiotics don't work, let's talk a bit about why ticks are infected in the first place with these bacteria. So I just briefly mentioned our intestinal system and how our body has, dozens and dozens and dozens of times more bacteria than we have human cells. And we have these symbiotic, mutually beneficial relationships with bacteria, and just like we do, so do ticks. And it just so happens that Borrelia is one of the considered sort of probiotic or beneficial bacteria that a tick wants in their system, because they help a tick to have all sorts of benefits. For example, a tick that's infected with Borrelia is less prone to dehydration, so it can quest longer for a host before it needs to go back and get some water. It also increases the fat reserve by at least 12%. A tick infected with Borrelia will move quicker, climb higher, live longer, and the Borrelia actually helps release an antifreeze type substance, which helps keep the tick active during freezing temperatures. So just when you thought you were safe for those January, February hikes, a tick wants to be infected. It actually is sending out a chemical signal when it bites a host. So if it's biting a host and it doesn't have Borrelia yet, it will actually send out a chemical signal that is calling Borrelia and other bacteria to it that it wants to be in its body. And my theory personally is that we are constantly doing this as human beings as well. We are exuding pheromones and exuding chemicals that are inviting various microbes into our bodies. And I believe that just like in nature, when a tree has a diseased limb or is diseased, it will send out signals that actually invite bacteria to come in and either digest that limb, and the limb will die off and the rest of the tree will be fine, or should the circumstances be right and the environmental conditions favorable, then the whole tree will be digested back into the cycle of life. And I think that because we are such a part of nature, we aren't separate from it. I think the same thing is going on inside of our bodies. And whatever conditions and environmental cues are going on will help invite various microbes into our body to cohabitate us or to break us down and focus on that cycle of life. And I really don't think that, even though Lyme can be such a devastating illness, I really don't think that they're an evil bacteria by any means. I think that something is going on in our body that's making us more susceptible to disease. And I think that if we really understood what was going on a biological level and on a spiritual level and an energetic level, that we would simply realize that we're vibrating at the wrong frequency and we're inviting these microbes to come in when they otherwise would not, and would not cause disease symptoms. So the ticks, basically the Borrelia is their probiotic, and it's not ours. So if it's bitten us and it infects us, and we have underlying conditions that make us more vulnerable, then we have a higher likelihood of having a chronic infection. So safe removal of a tick, of course, prevention of a tick or other arthropods is probably our number one strategy. If you know you're going hiking in the woods, you can wear light colored clothing so that you can see. Make sure you tie your hair up so that you don't have an extra, if you've got really long hair like I do, you don't have to worry about them clinging to your hair. You can tuck your pants into socks, and then you can keep something like one of those lint removers in your car, and when you finish your hike, you can roll the lint remover all over you, and anything stuck to you will hopefully come off on the lint roller, and then you can do just a check of your body. It's a good practice. I do it with my kids every night before bed. We do a tick check because we're always constantly outside, wandering in the forest and rolling around in the grasses in the garden, and I've been lucky several times to be able to catch ticks on my children before they've been on there very long. And you can tell if a tick has been on I mean, you can't 100% in case it was partially fed, but if a tick is very full on your body, then it's had longer to consume its blood meal, and it will puff up and get really swollen the longer it's been on you. So the earlier you can get it off, it's actually sometimes a bit more difficult to remove because the tick is not as swollen. And so make sure you get yourself a great tick removal kit that has a pair of nice long needle nose tweezers for the really tiny ones. And then a couple of those little twisty things for the larger ones are very helpful as well. I like the ones that can Lyme cells, that comes with a pair of tweezers and that have a magnifying glass on them, as well as some containers and tick ID tags to be able to put the tick into with a little bit of damp cotton so you can take it in for testing and keep it alive that way. If you kill the tick or squish it, then you're not going to be able to take that in for testing. It needs to be alive for that. And also, it's really recommended that you never burn or smother a tick with anything, because you can actually force the tick to panic and regurgitate its bacteria that are in the midgut faster. So if you just properly grab the mouthpiece and gently pull up, then you're going to have a lower risk of transmission than if you smother it or burn it or otherwise use some of these other methods that people have been talking about or sharing. So safe removal is really important. Stephen Herod Buhner, I cannot sing his praises enough. I would not know 90% of what I've learned about Lyme disease and Borrelia infection, and actually infection in general in regards to herbal medicine and I mean larger context, if it weren't for that man. So Stephen Herod Buhner is a brilliant herbalist, and he has done so much research and created some really just beautiful gifts to humanity in the books that he's written. I think I own and have read all but 2 of his books, and they are worth every single penny and many times over to have on hand. So if anyone is wanting to have a resource that they can constantly refer to, then I highly recommend his book about healing Lyme. And just want to, if you give him a shout out. Thank you, Stephen, for all your hard work and your contribution to not only Lyme disease, but all various types of viral infections and bacterial infections as well, in context of being able to rely on plant medicine to treat these conditions. So let's jump in and talk a little bit about herbal treatment for Lyme then. Just a note before we dive in, all of us are biochemically unique, and there's not ever going to be a one-size-fits-all approach for any protocol, and anyone who tells you that there is lying or trying to sell you something. You really have to take into account someone's unique biochemical makeup and how the illness is presenting for them. And so while there are definitely some broader categories that you want to make sure you're ticking off, there are numerous herbs that you could choose and numerous combinations, and doses for everyone is going to be very different. Sometimes you see really petite, 90-pound women who need massive doses, and you see on the other end of the scale, like very large men who need only a few drops of a tincture for it to be effective for them. And for some people, a small dose is more effective than a massive dose, and for others, they really need that larger dose. So it really is dependent on a person's individual makeup, and there is no right or wrong and one-size-fits-all approach. For preventing infection in the first place, keeping your immune system strong, as I mentioned, through paying attention to your stress levels, proper sleep, proper hydration, is really important. What you're eating is probably one of the easiest things. You get to choose every single day what food is going into your body, and you can really affect your immune system just by choosing foods that are lower in sugar, not full of artificial preservatives and other ingredients. Really fresh, vivid, colorful food is what we want to go for, that has all the essential proteins and fats and in a great balance. So excessive eating is also hard on the system and can create all sorts of problems. But for herbal medicine wise, preventing infection, astragalus is my favorite immune modulating herb, and it's recommended to take 1,000 milligrams a day minimum. And if you live in a really endemic area where Lyme is just explosive, then you can take up to 3,000 milligrams a day all year round. Some people just prefer to take that higher dose in the springtime or the fall, but it's fine to just go with how you're feeling on that and your specific area. But it is one of my all-time favorite immune modulating herbs for really strengthening that first stage of your immune system too. If you've got a lot of astragalus in your system, you're more likely to wipe out infections across the board before that you even notice symptoms. The other thing that Stephen recommends is to apply andrographis tincture and clay as a poultice for 12 to 24 hours on the bite site directly. And the homeopathics latum 1 mg 3 times a day, and if a rash appears, Apis 30C 3 times a day for 3 days as well. The other categories you really want to hit on are endothelial protection, cytokine remodulation, collagen protection, and immune modulating and biofilm breakers, and anything to treat the co-infections. So that's going to be your basis. For the endothelial protection, those are the cells that form an interface, like a barrier on the interior surfaces of our blood vessels, and that connects other tissues and fluids. So the Lyme bacteria break down these endothelial structures to feed and gain access into deeper parts of the body. I think we talked about just most of the damage that's occurring, the symptoms that are occurring is from that damage. So protecting those structures are really key to starving out the bacteria and denying them access deeper into the body. So for me, that would mean cut out any food that has glyphosate as much as possible. So choose locally grown, untreated, unsprayed, organic produce as much as possible. Unfortunately, because of our water contamination, you can't get away from it 100%, but do the best you can to make sure that you're not loosening your cell tight junctions further by consuming large levels of glyphosate. Herbally, Japanese knotweed is an amazing endothelial protector, as well as prunella, which is also known as self-heal or heal-all, and green tea extract. So to facilitate the breakdown of some of the endothelial tissues, there's an enzyme called hyaluronidase that is used, and there are some herbs that are potent inhibitors of this enzyme. One of the most widely known is Echinacea angustifolia. It has to be the angustifolia. The Propea will not do this. Another one is Chinese skullcap, Withania, which is also known as ashwagandha, and Triphala, Melissa, and rosemary are all really great inhibitors of that enzyme. Echinacea angustifolia is probably my favorite, and the Chinese skullcap and Withania are also used for various other parts of the treatment. So those ones, if you just are taking a high enough dose, you'll be covering many of the other bases, which we'll move on and talk about. So cytokine remodulation, this is going to reduce most of the inflammation and deny the bacteria of food. So the best ones for this is the Chinese skullcap, which is the Scutellaria bacalensis, and Salvia miltariza, which is Chinese sage. Also good are cordyceps, Japanese knotweed, and green tea extract, and olive leaf extract. Specifically for collagen protection, you want to make sure you're getting a ton of gelatin in the diet. So bone broths are a really great source, and you can also just use some gelatin as a supplement. Selenium and vitamin C nutritionally are also incredibly important for collagen protection. Selenium can be found in Brazil nuts in high quantities, so just a handful, like even 3 or 4 Brazil nuts in the day are a really good source of selenium. Specifically for herbs for collagen protection, kudzu root is really powerful. Echinacea angustifolia we've mentioned. Nettle, oat straw, horsetail, and parsley are also really helpful for protecting collagen structures. If there's neuroborreliosis, so it's affecting your neurons in the brain or throughout the body, then Chinese cat's claw, which is Uncaria rancophylla, and lion's mane mushroom are helpful for actually regenerating neural structures in the brain. And so that's going to help with the restoration and any damage that's occurring there. Another one that's really important for protecting the nerves and also the mitochondria cells in the heart that can be devastated for Lyme disease is motherwort. So motherwort is very neuroprotective and protective of mitochondria as well. Another herb that is helpful for nerve issues with Lyme is Polygala seneca. Chinese seneca is another name for that one. And melatonin taken as a general supplement will help protect neural structures as well. I just want to throw in a quote by Buhner here actually, and he says, "Little, if any, tissue injury occurs in immunocompetent animals." So little, if any, tissue injury occurs in immunocompetent animals, which means if your immune system is functioning the way it's designed to, and you haven't been hindering it with the wrong diet and high stress or injury, then you probably don't even have to really worry about Lyme as a rule. But if you want to help enhance your immune system, and especially after infection, the best immune remodulators for Lyme specifically are cordyceps mushroom, eleutherococcus, rhodiola, Chinese skullcap, Uncaria tomentosa versus the Uncaria rancophylla, which is for the neurostructures. But for the immune system, the Uncaria tomentosa, which is the other cat's claw, Withania, again, which is ashwagandha. And yeah, so those ones for specific for immune remodulation are my favorite and the most recommended that I can personally recommend for what I've tried, help with my own immune system and also helping various clients as well. Another thing that you want to do, because about 2% of the Borrelia bacteria will go into making biofilms right away. So if you've had a long-standing infection with Lyme, you can guarantee that you've got some biofilms in the body. So you want to use biofilm breakers, and Japanese knotweed, andrographis, rhodiola, and Chinese skullcap will all also help do this. As far as co-infections, those must be treated too. The best broad spectrum antibiotic that's very systemic I could recommend is a blend of Cryptolapis, Alcornia, and Sida. So any specific symptoms that you've got because of co-infections or due to your unique, whatever's going on for you in your symptom picture, you're going to want to use herbs that are addressing things like pain, sleep issues, low energy, Bell's palsy, tremors, memory, joints, behavior and mental health. All that kind of stuff is going to need to be addressed. Also, spleen protection is incredibly important when you have an infection with Lyme, and the best herb I could recommend for that is the Cyanthus, which is red root, as well as the Salvia miltoriza, which again is the Chinese sage. So none of this information I'm presenting is to create fear. It's actually the opposite. I want people just to be aware so that they don't have to fear some sort of unknown, and to also know that there are things we can do. And when antibiotics don't work, because that's generally the only treatment available by Western medicine, and that doesn't work for everyone, especially if the Lyme diagnosis doesn't occur for a very long time, then antibiotics become less and less effective. And for people with chronic Lyme that have tried antibiotics, there is a whole lot that herbal medicine can do for the body to support. And just to be able to empower yourself and learn and experiment is just really empowering, and I think an important tool that we need to be able to dependably use and rely on. The more that antibiotics are starting to not work as far as other bacteria infections too. Surprisingly, even though Lyme are so able to, they have all the resistance mechanisms in place and all these extra DNA segments, but surprisingly they actually haven't shown a huge resistance for antibiotics at this point. But where we're seeing incredible antibiotic resistance occurring at an alarming rate with many other bacteria that are known to cause diseases in humans, it really for me is only a matter of time before it eventually does occur with the Lyme spirochetes as well. And so knowing where we can turn with confidence to herbs to help support our bodies through serious infections is something that I think is really important and yeah, empowering for me, just to know that nature is so intelligent, and if we just turn to use the gifts that are already intelligently there and provided for us, then we can use them with confidence and just trust in the whole design and the process. So thanks everyone for tuning in for this episode 2 of the Wise Wellbeing podcast, and I look forward to getting another episode out as soon as I can. If you have any suggestions or questions or a topic that you'd really like to learn more about in regards to nutrition and herbal medicine, please send those along in an email. You can reach me at info@andrealarsonrncp.com. I also have a page on my website that you can submit questions, and you can find me on Facebook and Instagram at Andrea Larson RNCP as well. Thanks everybody, and have a beautiful day.